for today. Let us welcome Sri Narayan. A small introduction. Sir, welcome, sir. Welcome to the webinar. We thought of having the face-to-face, but unfortunately we couldn't do it. Maybe next time we will plan it. Warm welcome from the department and the university, sir.
Thank you.
A small introduction. Sir suggested me not to spend much time in introducing him, but still, as a courtesy, I just want to take 2 minutes for you, sir. Yeah, Sri Narayan. He is the entrepreneur and the founder for the Bangalore-based Radel group, and he holds a master degree in electrical engineering from IIT Madras. He was a part of the four-member team that built India's first indigenous cockpit simulator. He is an innovator from his childhood. You know that many of the students now you started working on the aeroplane models, but Sri Narayan, he started his passion from his high school onwards. He built the model aeroplanes and he was very active. I have seen many of his models. He's a very active person in making the flight models actually. On keeping the technical other side, the other point probably other focus I can say it's he is a multi-talented person, and he has the very great interest in the classical Carnatic music, and he himself is a expert flute. And again, he started because of his interest in the teaching. He started his school called Drona School of Engineering, where he is training our fresh graduate engineers and helping them to get their better careers. He has been conferred with many awards and honors from both the government and the non-government institutions. To just mention a few awards, he got the Ananya Award, Best Senior Musician. He got many technical awards. Apart from the technical awards, he got the many awards from the School of Music. Okay, sir. Welcome. I don't want to take more of your time. Welcome, sir. Once again, welcome to you. And it's over to you, sir. And yeah, a few rules we need to follow. Students, please give your attentive listening to the Sri Narayan's talk. What you do is, if you have any questions from your side, please keep them in the chat box. At the end of the session, we will go through the questions, what's available in the chat box. We will try to get the answers from Narayan. And apart from that, if you want to speak something, probably you can raise your hand. Maybe based on your request, we will allow you for asking your questions. With these things, once again, welcome, sir. Over to you, sir.
Thank you, Professor Ramkumar, for this lovely introduction. And good morning to all the students and faculty, whoever is online to listen to me. At the outset, I would like to thank DSU for this honor of talking to all of you. It's always a pleasure to speak to youngsters in particular, because elderly people like us, we want to share our knowledge. There's no point in keeping it bottled up or sealed within our brains anymore. We need to share it so that you people don't need to reinvent the wheel. So whatever we learn, we have learned, whatever knowledge we have acquired, we need to pass it on to the younger generation so that you use that as a stepping stone to fly higher. So with that intention, I like to speak to youngsters, particularly in engineering colleges, and I hope that I get many more opportunities like this to speak to all of you. Let me briefly introduce the subject.
Sir,
Yes.
Sorry for interruption.
Yes.
Some people, they are saying they are not able to see the video. Students, are you able to see his video? Hello? Are you able to see his video?
I think whoever wants to speak should unmute their microphone and then speak.
I think that's fine, sir. Yeah, carry on, sir. Now they are saying yes. Please carry on, sir.
Okay. How do I do screen share? Yeah, I will share my screen. Just 1 minute. And how do I go back? You are. Are you people able to see the screen?
Yes, sir.
I've shared my screen. It says Foundation for Innovation.
Yes, sir. We are able to see, sir.
Very good. So this is the topic. I can manage. Let me just give an introduction about what this is all about. Innovation is the buzzword today. And you find that every day, whether it's a video or a WhatsApp or anything in the social media, innovation is a word that you very frequently hear or read. I'm sure a lot of people are using this just to stay in the limelight. But I think it's important to understand what exactly innovation is all about and what is required to nurture anybody to get into an innovative field or even to engage in innovation. So I'll take a minute or two to explain the requirements for innovation to flourish. First of all, what is innovation? Innovation is, if you look at the dictionary, it will say to do something in a unique way, in a different way, or in a new way. It can be a product, it can be a process, or it can be a new gadget or a different method of doing something, or even a different process to manufacture an existing product. So the innovation can be in any field, irrespective of whether it's engineering, medicine, journalism, media, anything. So to do it differently from what it has been done all these years, you need to have a mental makeup to say, can I do it differently? That means you must have the ability to question, if you are asked to do something or you're doing something, am I doing it the best way? Can this be done differently to gain some advantage, either in price or in quality or time? That is what is required to get into anything that is innovative. Now, let me get into, one more thing I want to say, because it's important to say this in this talk, because I presume there are not only students, but faculty members and hopefully administrators of the Dayanand Sagar University. You can be innovative in the way the subject is taught. You can be innovative in the way the university is administered. You can be innovative in the way an industry solution is found. So there are multiple infinite methods of getting into an innovative mode. So let me move to the second slide. Okay, I now come to what I call the value pyramid. So a lot of people, whether it's an industry, manufacturing industry, it's an IT industry, or even a workshop, a garage, a shop, there are different kinds of activities being done. So let us confine ourselves to an engineering industry. So in engineering industry, you can have, in most cases, you would have a manufacturing industry. So the first level of the value, I would say the lowest level, though I'm not trying to play down manufacturing, please don't get the wrong idea. Manufacturing also has large value addition, but I'm talking about relative value addition. So manufacturing comes at the bottom of the pyramid. So manufacturing happens in large numbers. You have a industry manufacturing buckets, plastic items, electronic items. So serial manufacturing day after day, month after month, and year after month, year after year. So this would be low value addition, but large volumes. So there is profitability, there's large production, large sales across the country or maybe globally. So that's the lowest level. The next would be what I call design. So instead of just manufacturing, if you add design value to the product being manufactured or a process being offered, there is the higher value. Because you have designed something, you hold the intellectual property right of that product or a manufacturing process, and then you have the ability to redesign, upgrade, and come up with newer and newer designs. So that's a positive feedback loop where the design value addition is repetitive. And once something has been designed, it goes on down into the lower level of manufacturing where maybe one person designs, 100 people manufacture it. So you see the value addition of design, it's much higher, but it feeds the lower level of manufacturing. Next comes the conceptualization of a design. Now, if somebody gives you a plastic part or an electronic product and says, you design this, you have something as a reference, and based on that, you design or more or less try to replicate that design in your own way, and then complete the design. Conceptualization is something one level higher. So you don't have a reference design at all. So somebody said, I want a product which can do this job. Can you come up with something that can do this job? An input output is specified. You need to design or conceptualize that product and then get into design and then manufacture it. So you see that conceptualization is more difficult than just design because you don't have a reference design. You don't have anything to see. You don't have anything to read about. So you have to conceptualize it in your mind, either singly or as a group or as an organization. And then once the concept is there, it's like saying, okay, I have a block diagram. From the block diagram, I conceptualize the design of each block, then get into circuit design or mechanical design, thermal design, hydraulic, and then go into detailed design, and then ultimately pass on the manufacturing drawings to the workshop where manufacturing happens. Now, higher than conceptualization is where the question of innovation comes in. So as you see, innovation is at the top of the pyramid. The highest value generation lies in innovation. So I have already said what innovation is. So you might have a design, you might have conceptualized something, but then in the process of conceptualization, you say, instead of using a hydraulic solution, let me use an electro-hydraulic solution or an electronic solution or a pneumatic solution. So nobody's done that earlier. Now I'm trying it for the first time, saying this may be a better way to do it. So that is where the innovation comes in. So innovation, anybody can do, no doubt. Even a mechanic in a garage can be innovative. But then when you are talking about real innovation in an engineering sector, you need to have certain basic requirements in terms of the education, qualification, experience, and so on and so forth. There are a lot of requirements without which innovation may be just skin deep. You won't be able to do a thorough innovation going into the depths of the design, depths of conceptualization, and then the depths of design, and then the depths of manufacturing, because one needs to know, this is a very, very large topic. So if I get into the details of each of these, it'll be a 1 hour talk on each of these, because you can't just design without knowing what manufacturing is. design has to suit manufacturing. So conceptualization has to suit the design capabilities. Innovation has to suit all these lower levels. So innovation is easier said than done. So that is where you need to be aware of a lot more things to effectively innovate, because this is where the difference in the way I use the word innovation and the way it is talked about in the social media or in the media. They're talking about, say, innovative India. There are a lot of innovation happening in India. At what level is it happening? Is it skin deep, or is it to the depth of real engineering, hardware and software and so on? That's where this talk is all about. Let me now move to the next. So in order to enable or facilitate innovation, and that too at a high level, you need what is known as an ecosystem. Now, again, the word ecosystem, I don't know how well many of you have understood among the students I'm talking about. You can ask yourself this question: what is an ecosystem? And see if you're able to answer it. Just to help you, I'm going to expose you to certain basic elements of an ecosystem. See, for example, in automobile sector, you say that we have a very good ecosystem built in because of the coming into the country of various MNCs like Hyundai. Of course, Maruti is our own, but with Japanese help, and various Korean manufacturers. So they brought in their automobile factories here to manufacture. So once the factory is there, you need manpower, and that to trained on automobile technologies. Then the supply chain, manufacturers of rivets, bolts, nuts, plating, electroplating, painting, all kinds of things, sub-assemblies, machine parts, CNC machine, conventional machining facilities, all kinds of things. And then if you need manpower, you need training institutes. So you see that the ecosystem is very large. It goes right into academic institutions, it goes into manufacturing, ITI training institutes, all kinds of things. Same way, for innovation to be facilitated, you need a suitable ecosystem, and that starts with basically knowledge. Anybody who wants to innovate should have sufficient knowledge to know everything about what he or she is wanting to innovate. If it's a plastic part, he or she should know everything about what plastics are, how they are manufactured, how can they be molded or created different shapes, tooling, various things. And that doesn't come right away out of a college. It comes out of skills. I hope everybody is able to see the presentation I'm sharing as I'm.
Yes, sir.
So I hope you are all able to see that knowledge and then skills.
Yes, sir. Yes, sir.
Now, again, a lot of people talk about skills, and most people associate skills with an ITI training institute, industrial training institute, where carpentry, machining, turning, milling, those things are taught. Skills are far more than that. Skills go right up to PhD holders and then getting into active projects. So now a person develops or converts knowledge into skills by doing something. That's where experience. Just by going through a college or school or a university, you acquire knowledge, but that knowledge is of no use unless you have converted that into skills. And those skills have got to be proven skills through the process of experience. Now, I want to spend most of you students, or for that matter, many employers also will say, experience, 4 years experience in an industry. According to me, that 4 years has no value if it's just a question of going to an office, marking attendance, and then coming back home, drawing a salary, of course. So, experience has value only if during those 4 years, the person has done something, in other words, executed some tasks, and through that process, how does one execute a task? By using skills that he has developed, and that skill is based on knowledge. You see, that Knowledge leads to skills, and in other words, knowledge needs to be converted to skills, and those skills need to be applied in doing something to generate experience. Only then I will consider that as an experience if somebody has done something over that claimed experience period. So one of the things I ask prospective employees who come to me for an interview is, tell me what you have done and what you are capable of doing. I don't bother, I just don't go into their marks card or their degree certificate at all, because it doesn't mean anything to me. So I only need to know what they are capable of and what they have done. What they are capable of is proven based on what they have done in their so-called experience of 2 or 3 or 4 years or whatever it is. And that is where I find everybody fails, because they are not able to clearly explain what they have done, because it's not just a question of doing. If somebody asks me to go to some other place and hand over a letter, that's all I have done, walking up and down. But as an engineer, if I've done something, I should have understood what I am supposed to have done in an engineering term, and then applied that suitably to understand the engineering basic. And then, of course, there would be failures in that. I would have analyzed the failures, learned my lesson, and go back to improving the knowledge and improving my skills. So it's a closed feedback. Are you people able to see me, my face also, along with the presentation?
Yes, sir.
Thank you. Because that's very important, because unless you see my face, you won't understand my expressions and my hand movements. That's equally important.
Yes, sir. Yes,
so,
sir.
You see, this is the point that I want to drive home again and again among the youngsters in particular. It's not a question of going about with a degree certificate, because nobody is going to ask you about your degree certificate once you have got into a job. The degree certificate in your marks card is only used at the first level of filtering. Subsequently, nobody cares about it. But according to me, even at the first level, your capabilities and skills are more important than your degree certificate or marks. So acquiring knowledge and skills right from school, it's not the university. Unfortunately, it's very unfortunate that our education system, right from school, it kills the curiosity of children and their ability to converse and express themselves in their own language, whereas the teachers say, don't change the words, reproduce the words as it is in your textbook so that you can get more marks. That's the focus should not be on marks, it should have been on learning and understanding the subject, acquiring skills, converting that into skills, and then applying it. So even in a high school or even in a middle school, the process of arithmetic should have followed this process of acquiring knowledge, converting that into a skill of addition, multiplication, solving problems not solved in the textbook, but an original problem which has not been solved. That's where your application skills are tested, and there you can be evaluated, and if you get good marks, that means your analytical skills and your ability to learn and acquire knowledge is proven. That should have been the focus in our education system, but unfortunately, it's not so. Let's not get into that now, but at least I want you people to be aware of this. Now this on the one side, now if you have got this correctly of developing experience, I have not yet got into innovation so far, right? So I'm saying that knowledge is at the core of the ecosystem required for innovation to flourish. And knowledge needs to be converted into skills to experience. So thereby your knowledge gets strengthened. Now I add the next, that is you need facilities. This is where I will compliment DSU, because you have established an excellent network of labs, conference rooms, all the facilities that are required as a facilitator for this innovative. And I'm also happy that I'm talking to students in the innovation campus. So you can relate to this by going around your own campus, and you'll see that your facilities in the various labs, and also the fact that you have many startups working there, you can go there. though primarily they are on the IT side. But if you are able to visit engineering industries who are also into design, innovation, and other product development, you will get the picture on the other side of the software side. That is, I'm on the hardware side. So facilities. So if it's an engineering industry which is into hydraulics, you must have a hydraulic workshop. You must have facilities to carry out experiments. You get an idea, you want to immediately carry out an experiment, see how well it works. So the laboratory, experimental facilities, workshops, whether it's in-house or you have a partner, you can always have a partner, a host of partners, one with hydraulic facilities, one with electronics facilities, one with electrical, mechanical, and so on. So as long as you have access to these, you have the facilities. Next comes resource persons. Now you have your own knowledge based, your own skills, your own experience and the facilities, but you have not been exposed to lot more areas, because there's one thing I want to emphasize once again here. Innovation happens much better and if you have a wider base of knowledge across disciplines. When I say disciplines, I'm talking about mechanical engineering, electrical engineering, electronics, hydraulics, pneumatics, and so on. Wider the exposure, you need not be a specialist in each of these. But once you are at least exposed to these, you are able to look at any problem from either a mechanical side or an electrical side or an electronic side or software side. So you're better able to appreciate the problem and understand the problem, because once the problem is understood, you say you're in a much better position to say, okay, maybe a hydraulic solution is better for this, or an electronics solution is better, or a pneumatic solution is better, or an electromechanical. All kinds of things can be discussed, and that is where resource persons come in. You can have a resource person specialized in electronics. You can have another resource person specialized in the mechanical field. And since this talk has been organized by the aerospace department, an aircraft is a completely multidisciplinary platform. It has a lot of electronics. It has a lot of mechanical engineering. It has a lot of aerodynamic characteristics, aerostructures, hydraulics, pneumatics, you name it, you have everything, all disciplines. And therefore, if you want to be in this aerospace domain, you need to have at least a basic information of mechanical engineering, electrical, electronics, hydraulics, all kinds of things. And even an aircraft, when it's flying at high altitudes, exposed to UV, infrared, all kinds of things. We talk about radiation hardened electronics to be used in military aircraft. So what is radiation hardening? It can lead you to all kinds of areas. But to be capable of appreciating a multidisciplinary exposure, again, facilitates and encourages innovation. That's the point I want to make. And that's where resource persons come in. You must have access to resource persons to whom you can say, I have this problem. Can you tell me how this problem can be solved from an aerospace side or a hydraulic side or an electronic side? Get all the views, and then you have a much better appreciation of the problem. Then you have the ability to find a solution. It can be very innovative. And next comes, for all this to happen, all these 5 parameters that I've talked about merge to get together to create a thought process. Now, thought process can be in an individual, it can be a group of people, it can be across an organization or a university. When you have a problem or you want to innovate on something, it becomes a group activity. Not that it cannot be done by an individual. You do have individuals innovating something, but then that individual has an in-depth understanding of, let's say, an agricultural farmer. He has a thorough understanding of agriculture, the problems of not getting water, the problems of not getting rain when he wants, the problem of not getting sunlight when he wants. So he says, this is required, how can I solve it? By either putting a LED light to simulate sunlight, because that is being done now. Or bore wells, automated bore wells, or water harvesting, so many things. So an individual with a thorough knowledge in a field can also innovate. But I'm talking in the more general sense from an industrial concept, that innovation happens when a group of people, and knowledge, and all of them together start discussing problems, and there is a thought process in each person's mind to say. And what is a thought process? Basically, to understand the problem, analyze what is the core problem issue to be solved, and then to try and think about solutions using all the things that I have talked about so far. So all these 6 parameters that I've highlighted is what facilitates and adds to an innovation ecosystem. And once you have an ecosystem like this, and this is what is typically characteristic of the Silicon Valley in California and US, everybody there is innovative, because if you put a person into an environment where everybody is thinking, everybody is working, everybody is innovating, everybody is dreaming big, you will also start doing it. You look at all the Indians who have gone from here to the US, they're all at the top of their organizations. How? All of us have the same amount of gray matter. All of us have graduated from similar universities in India, gone abroad, got into that ecosystem, and then you start using your gray matter. You are encouraged, you are appreciated, you go up the ladder. Ultimately, you become a CEO of one of the global MNCs. There are so many of them. I don't have to name them. You are aware of all of them. This is what happens. And I believe that this needs to be created right from our schools to the colleges, to the universities, and to the research organizations. Of course, industries included, but predominantly industries are into manufacturing, repetitive manufacturing, and more particularly MSMEs. Innovation and R&D is expensive. So unless you are sure about recovering the expense you incur, MSMEs will not spend money on R&D design. So you need to create this kind of a facility in colleges, universities, so that then you partner with MSMEs to manufacture. It's a partnership that's beneficial to everybody, all the stakeholders. If anybody wants to interrupt me with a question, feel free. I only have another 2 or 3 slides. I plan to have about 10 minutes at least for a question and answer session. I think I'm going on schedule as of now, but if anybody wants to interrupt me, you can maybe raise your hand. I'm not able to see all of you, but maybe Professor Ramkumar can coordinate this. Now, moving to the, yeah.
Would you like to interrupt the question now, or would you like to answer the question now, or at the end of the session you want?
I think I will reserve it for the end of the session.
Okay, sir.
Or you can note down your questions and then feel free. And I would definitely encourage each one. More the number of questions, happier I'll be.
Yes, sir.
Feel free to ask any question. Don't hesitate. Don't be at all diffident.
Thank you.
So the next slide, I'm trying to associate each of these parameters that I have described in terms of their value contribution towards innovation. Now, ultimately, I will show that knowledge is at the core. Then that is what I have been repeatedly telling all of you. I already talked about facilities. Certainly, facilities are required. Without facilities, whether it's a lab or a workshop or a university or a school, even in school, you should have labs where children are encouraged to go and tinker around. That's not done these days, from what I hear. I mean, during our days, we used to have chemistry lab, physics lab, where we could go in and carry out a lot of experiments. Even in our lecture classes, the experiments used to be conducted in front of the students sitting in the class. I don't think this is happening at all today, but definitely in a university level, you people, the students, should be empowered to walk into the lab and play around, fool around, do anything to acquire knowledge. Because as I said, I want to repeat this again and again and again. Doing is what you, only by doing something you learn. Without doing, you can't learn. No amount of reading. You can read books after books after books. You can't read, and you would only have read, but you won't have understood or acquired the knowledge till you apply that knowledge to do something. So you need to do things in the lab or in industry, in a workshop, to convert that knowledge into a skill and then reinforce that knowledge. So you need the facilities. That's the starting point. The next is the thought process, which I've already explained in fair amount of detail. Then the experience. This also, again, I told you that if you have experienced, and I would like to once again state here that experience does not exclude failures. In fact, you learned more out of a failure than through a success. If somebody has achieved success at the first time, they call it beginner's luck. By fluke, they call it. But if you've attained success in the first try, definitely in the second level or the third level, you will have a greater fall. So I say that it's better you experience failure at the lowest level rather than failure at the highest level, because the cost of failure will be higher and higher at higher levels. So get used to this fact that failures are a part of life. Most people have the fear of failure. Even I had. And this is one of the main things why students don't ask questions in a class, because they say, what if people make fun of me if my question is perceived as a stupid question? Some teachers also reprimand the student saying, why are you asking this stupid question? That shouldn't be done. Now, even if it's a stupid question, there's a nice way of answering and setting the doubts at rest for the student. Because believe me, no student asks stupid question just for the fun of it. A question has to be asked. Very often, many other students at the end of the class would go to the student and say, I'm glad you asked that question. I had the same doubt, but they didn't have the guts to stand up and ask. So it all starts with having that confidence in you to say, I have a right to ask a question. I want to ask. I want to learn. So start now. At the end of this talk, start asking questions. So that's where I'm saying this experience includes asking questions. If you asked a stupid question, next time you'll be more careful, provided everybody supports you, encourages you. So it's a group activity. Everywhere you have a positive feedback, a closed loop mechanism. So you must have the experience of asking questions, getting doubts solved, learning through it, and apply that improvised knowledge to solving problems, and then you can call that experience. So experience is required. Then the skills, I've already talked about it. So at the core of everything is the knowledge. Knowledge is the heart of design, heart of conceptualization, heart of innovation. So why I'm emphasizing so much is that the general complaint from industry today is that our graduates coming out of any college, be it an engineering college or a arts college, commerce college, they are not having skills to get onto a real job. They need to be trained. That's because the knowledge has not been converted into a skill. If you had converted into a skill, an accountant would be able to get onto an accounting job from day one. Maybe not do a very elaborate profit and loss analysis, but at least basic accounting, he or she should have been able to do it. An engineer at least should have been able to understand a basic drawing or make a drawing and hand it over to a workshop, a hand sketch in a 3D view. And this is again, most of the engineers today feel drawing is something you don't need to learn. I believe that in many branches of engineering, drawing is not a subject at all. I've done civil engineering, I've done mechanical engineering, I've done electrical engineering. Drawings. During our engineering course, 5-year course, 3 years were common. We studied as much of civil and mechanical engineering as electrical, which I ultimately graduated in. And that is what I'm talking about as the multidisciplinary exposure which gives you a real advantage over a person who's only learned electronics or mechanical or any other field. So, and let me again point out that you don't really need to go through a formal course like an engineering degree to acquire knowledge. You can do it on your own. I'll show you in the subsequent slides how I learned, how my son was exposed to various kinds of activity at home. And I also grew up like that. And this is what reinforced my learning in college and school and engineering. And by the time I came out, I had sufficient amount of skills which was appreciated when I got into an industry. So knowledge is core, and you need to focus on it to not only acquire knowledge, but reinforce it continuously, and there is no end of learning. I'm learning even today at the age of 72, I'm still learning. And I'm quite sure that all professors, all lecturers, everybody in industry needs to go through a learning, because technologies are changing, everything changes, everything upgrades. You need to be able to learn. That can be a part of a separate lecture. I call it the art of learning. I won't spend too much time on that. But art of learning is something, once you master that, you can learn anything. Let me tell you that. So now I'm here comparing the acquisition of knowledge to a tree. You know, a tree, before it becomes a tree, it's a plant. It's a sapling. It has just maybe one small root, and you plant it into the ground. Then it develops the trunk. Then you get the branches, and then you get the leaves, and then you get the fruits. But by the time it gets fruits, the trunk would have grown. And as the trunk grows, the roots also grow. And I'm comparing the roots to the knowledge. And the trunk is the experience. The fruits and the leaves and fruits are the skills. Ultimately, the fruits are the use of all this. The ecosystem yields you fruits. So I hope you are able to appreciate. So over a period of time, as the tree grows, you can see that the knowledge, which is the roots, also grow. This is something that you need to appreciate. Knowledge keeps on growing, and if you don't use this closed loop mechanism as I have described to add to your experience, that tree will die. Which means your knowledge growth also dies, the tree will die. If the roots don't grow, the tree will die. So this is something, I hope this remains in your mind forever, because pictorial explanations don't disappear very easily. You will retain it for a very, very long time. That's why I am explaining a lot of things through these slides. So it's important to continuously keep learning. So this is the screen where I was telling you that you see on the left top corner, that's me on the left, and my son as a little kid trying to understand the innards of a bicycle wheel. This is his own bicycle, small little bicycle that he used to ride when he was hardly 7 or 8 years old. And one day I told him how to take out that wheel, take out the tire and tube, and then dismantle the shaft and look at the ball bearing which is inside there. I had done this when I was a kid because my father, you can literally replace me with my father and my son with myself. The picture would have been the same 60 years ago. I went through this. So I gave the benefit of this to my son. And then the bottom left photograph is the same guy trying to build an aircraft model, a glider, using a drawing. You can see that blue drawing. Those days, this is taken 40 years ago. So we used to have blueprints. We never had computers those days. We didn't have CAD and so on. So everything had to be printed drawings. So he is referring to a blueprint of an aircraft model where the fuselage and the wings, everything is there. And he is cutting balsa wood to shape, sanding it, attaching it, and then building the model himself. So he's doing, and that's how he developed, not only he learned the art, he also developed an interest in aerospace. And today he is a PhD in aerospace working in an advanced design organization in the US. The right bottom, you can see him working on a vise on a work table inside my house. The photo is inside my house. So this is the kind of environment that encourages learning, multidisciplinary exposure, and then ultimately it will lead to innovative mind. The top right photograph is you see a bunch of students in a small hobby workshop that I conducted in the Electronic City. This was about 5 years ago. These are high school students from government high schools in the vicinity who had no exposure to any craft work or any such thing. They come from very poor, economically poor families. So for the first time, we gave them cardboards, paper, scissors, Fevicol, and they built, you won't believe it, I don't have pictures right here, but I have it in my phone. They created scale models of a railway carriage and a scale model of an Airbus A320 to size. They cut the cardboard, folded it, pasted it, they created the fuselage, then they attached the wings and the tailplane. They had everything on it. Painted the windows, cockpit windows, the blunt-nosed nose cone, everything I taught them. This was just 10 days and they enjoyed it. And I'm sure they won't forget it for the rest of their lives. That's what learning has got to be. So the art and craft of learning, Professor Ramkumar or anybody in DSU can make it into a separate talk. I will talk about for an hour. So what I'm trying to highlight here is that this environment and the ecosystem that I talked about all this time needs to be created right from that young age, because that's when kids want to learn, their curiosity is settled, it is quenched. You need, whatever questions they ask, whatever doubts they have, it needs to be solved there, and they have to be fed and incentivized and supported and encouraged. Only then it develops into a habit. Let's move into, I think this is my last slide. So here I'm trying to address and say that it's not just the students who need to learn. The students need to be assisted by the teachers, professors in the education institution right from school. The teachers need to inspire the students. They need to facilitate activities by providing them the lab facilities, handhold these students, encourage them, be it successful, unsuccessful, you still need to encourage them. Once again, I will say failure is not nothing wrong. You need to encourage them. So you need to experience failures, analyze the failure, why it didn't work, what went wrong, and then convert it into a positive success next time you attempt again. You need to attempt it again. The teachers also, professors, need to see what kind of a approach to teaching will suit the kind of students that you have. The same method will not work on anybody. A student coming from a rural or a outskirts of a city or a rural background will need a different approach compared to the students coming from a completely urban area. So you need to mix and match and adopt these different methods to explain subjects, explain concepts to students in such a way that they are able to appreciate it and understand it. So this is where I say innovation in teaching needs to be adopted. Institutions, you have to create and enlarge the ecosystem, learning ecosystem. Right from school it has to happen, but I'm not addressing school students right now. So I say do it at least in the university level. It is a little too late because by then, if the students have already been put into this rote learning system, then you need to undo that. It's a harder task to undo something than to, of course, undoing in a computer is just one button on the mouse, but physically to do it in a mind of a child is far more difficult to do it. So that's where I'm ending. Now I'm open to questions. I think I've met my time limits very well.
Thank you, sir. It's a great talk, sir. Wonderful. You have covered many aspects which are required for the innovation. You have covered the requirements from the students, requirements from the faculty members, and also requirements from the institution. It's really great to know, sir.
Very good.
We have some couple of questions before
Yeah.
going that. I just want to say my comments, add some
Yes.
more comments. Sir, as you rightly mentioned, it's all about what we are capable to do. That matters. It doesn't matter what we know. In many of the webinars or the people what I heard, it's all they are looking for the what we are capable to do. Probably we may know 100 things or 1,000 things. We could have learned something, but at the end of the day, are we really able to capable to do that, produce that? That's the matters.
Correct.
You rightly mentioned, sir.
Correct. Correct.
As a part of the university, we are trying to do for creating the facilities and infrastructure. As you have already seen, we have good number of the innovation labs. Apart from that, in the department labs also, we have the sufficient infrastructure. But our honorable vice chancellor and vice chairman used to say, infrastructure is a kind of the just a body. Thing is, the way how we are utilizing that is the kind of the soul.
Very correct.
So
Very correct.
unless we have the body and soul, it doesn't work.
Correct.
So yes, sir. So regarding the body part, we are really fortunate that our management has taken the sufficient care, and they have created the good facilities here. But it's the turn with all of us, students and the faculty members, how to utilize that and how to make the products out of that. It is definitely yes, sir. That's it's a big job, definitely. But at the same time, we are happy to do some baby steps we started, sir. And our students are also really good in coordinating and cooperating us. They also understood the importance of that. As a part of that one, we started something like mini projects, sir, just for your information. Probably when you come next time, we will try to show you what's the works they are doing. And apart from that, we are encouraging the students to come up with the workbooks, sir. At the end of the day, what we are trying to say is from the each semester, we are encouraging to make a small report on the things what they have learned and what they were able to do it in the either laboratory or hands-on experience, and what's the projects they are doing. So every semester we are trying to ask them to make a small report, and we want to keep them as a kind of the workbook. Yes, sir. And the other point you have rightly mentioned is about the multidisciplinary. Yes, sir. As aerospace engineers, we all know the importance of that. And at the same time, we also encourage the students to do the mini projects, to do along with the other streams, not only learning, but doing those things.
Now,
Yes, sir.
can I just interject? Can I interject for a minute? Because when you said about multidisciplinary,
Yes, sir.
your students and many of you may be surprised that I possess skills in masonry. Any masonry repairs at home, I do myself.
Oh, wonderful.
Any electrical wiring repairs, I do. Appliance repair, right down to stripping an LCD TV, I have done at home.
Oh, wonderful,
Okay,
sir.
and then painting my house, gardening in my house, everything. When I was smaller in my factory, I used to assemble my own PCs, load the software. So there are multiple activities. Now, I can talk about this for hours because that is what gives a person the confidence to tackle unknown problems.
Yes, sir.
The argument inside me, in my own mind is, if I have got so much skills and I have proven skills where I have successfully done so many varied, multidisciplined tasks, there's nothing I can't do. That's kind of confidence with which I tackle something.
Yes,
And
sir.
that's what every student needs to aim at.
Yes, sir.
So
Yeah.
you can start small. But again, the core to all this is you must be interested in something. Whether it's aerospace or mechanical engineering or electronics, you must be interested. Not got into a branch because you got only that based on your marks. No, you have to, even if you have got it based on marks, get deep into it, learn to enjoy it, and have fun with learning that branch of engineering.
Yes, sir. Yes, sir.
That's
Yes,
again the core.
yes, sir. Fortunately, the all students of aerospace, they have selected, it's based on their choice only, sir.
Very
Even
good.
though they were able to get the other branches, but because of their interest, they
Very
have
good.
chosen that. That's really, I should congratulate once again all of them. And at the same time,
Good.
they are showing their interest, sir. Only thing
Good.
is, no, as a part of their race, sometimes they deviate little bit. There we need to guide them. Otherwise, they are really good, sir. They are very, very capable and they are more interested. And people like you, if you can help them, I'm very, very confident that they will have the very bright future, sir.
Sure. Sure.
Yeah.
Sure.
And I'm really happy to know all the things in your house are made by you. And I'm really surprised to see the energy in you at the age of 72, sir. You
Thank you.
yeah. And the other thing is the confidence what you mentioned about replacing your father with you and you're replacing you with your son. It's really awesome, sir. Hats off to you. And
Thank
I
you.
know about your son with the little
Yes.
information what I have. Yeah, he is also kind of the multi-talented.
Yes.
Even though he's a PhD in aerospace, he's working in many areas. We are trying to have probably some more sessions. We request him on the kind of webinars. Anyhow, now our students are also getting habituated for the webinars. We will work
Good.
on that.
Good.
Slowly
Good.
work on that.
Are there
Yes,
any other questions from the students? I'll be happy to answer.
yes, sir. A couple of questions. One question is about the innovation, especially on the fear of failure. One student is asking, will innovation lead to a definite result?
I think it's difficult to answer that. It may not, but it will lead if you have a good ecosystem. Once again, that is the answer, that if you have a good ecosystem, the innovation will definitely lead to something positive, maybe a new product. It can even lead to an invention. There is a small difference between an invention and an innovation. So if the innovative method adopted leads to a new product or a new process, you can get a patent for it. And then it can be capitalized by selling the patent to various people, industries, organizations. So it would have a higher probability of success if you have the right ecosystem.
Thank you, sir. The other question is generally whenever we want to start our own business, we always start with the a money point. So the question from the student is knowledge is the only resource required for the success or something else also required? Something like money along with the knowledge.
Okay, let me speak from my experience. I was an aerospace designer working at HAL. I worked there for 10 years. Then I got frustrated because in a different PSU, you don't have the kind of freedom to do what you feel is innovative, what you feel you can do. So with a lot of red tapeism, I got frustrated and quit without even knowing what I was going to do. So I just quit. Like I said a few minutes ago, I had the confidence that I possessed a lot of skills. And with those skills, I can get any other job or I can do something on my own. That was the confidence with which I submitted my resignation. And once I came out, I started an industry. Somebody mentioned to me that BHEL was going in for some outsourcing of various very small electrical components, and why not I look at it? I went there and looked at it. It seemed quite feasible. All I invested was 10,000 rupees on a coil winding machine. And that 10,000 rupees led to, I started on a labor job where I had to wind some electrical coils and supply it, and I used to be paid labor charges. But then over a period of time, I said, oh, instead of just taking the material from you and doing it, I will buy my own material. So the value addition increased. And then parallelly, I started working on my musical instruments. So I started designing things. I started innovating. And that's how today, Radel is a group of two companies, one into aerospace, one into electronic musical instruments. The musical instruments are known globally across the world because we invented the electronic tabla, we invented the electronic tambura, we invented a whole range of musical instruments catering to Indian music. So the point I'm making is that the initial investment was only 10,000. Even if 10,000, you look at 10,000 way back in 1979, even if you multiply it by 20 times over these 40 years, it would be what? Still affordable. Today, 2 lakhs or 10 lakhs is available at the asking if you have a good idea. If you have knowledge, you can raise those resources. If it's an IT, you have venture capitalists running to you because they see a startup in you. If you are in a manufacturing sector, banks will definitely, government also has collateral-free loans available to startups and MSMEs. So you can. Money is not really a problem today. There are enough and more people willing to give you money if they see value in you. So the knowledge is again the core, the capability to do something. Now, again, knowledge, I'm talking as skills. And the proven skill saying, okay, if I've done so many things, I've demonstrated that I can build a robo, I can build this, I can build that, then people see value in that. So there are no limitations. Only thing is you must have self-belief. You must be confident that if you take up a task, you will finish it and successfully, and not be afraid of failures, then you will succeed.
Yes, sir. Thank you. Sir, would you like to add something from the Elshia's point of view, sir? You are the very key person in Elshia. And I have seen your industry. I'm really impressed with the work what you are doing. Probably we will try to make a tour with the students when we come to the normal position. That we will try to do, sir. But apart from that, would you like to share anything from the Elshia point of view? Are you supporting the students' ideas in kind of the incubating the idea and nurturing the idea? Anything from the Elshia point of view, sir?
Let me say that the electronic city is very, very unique. In the whole country, this is the only industrial estate where you have a lot of high-tech work, both in the software and the hardware. You have both hardware companies, MSMEs, as well as large companies. You have the Tata Power, you have Moog Controls. These are all MNCs which are operating in the electronic city. And then you have MSMEs specialized in medical equipment, musical instruments, defense, aerospace, all kinds of. So it's an area, and all the promoters and CEOs in these organizations are well-read, well-qualified, well-experienced. So interacting with them itself and visiting many of those industries and organizations itself will open your eyes about the possibilities, about how to set up an industry, how to go about hiring, getting things done. So that's one side about the organizations there. On the other side, it's multidisciplinary. So you get exposed to, machining. A lot of people, MSMEs into CNC machining, catering to aerospace, catering to automobile sector, catering to foreign companies. So that is an exposure. Electronics, mass manufacturing, what do we call electronic manufacturing companies? Those are also there. We also have in-house electronic manufacturing facilities. So you have exposure to a wide range of disciplines in the electronic city. You have access to a lot of experienced people who would be willing to talk to you and converse with you and give you knowledge, add to your knowledge. Plus, we have recently, in the last 3-4 years, we have created a cluster there of MSMEs who have all pooled resources along with financial support from the government of India and the government of Karnataka. We have set up high-tech manufacturing facility which is shared by all the MSMEs. So if I'm an electronics industry, I don't have machining facility. If I need to machine something, I go to this cluster common facilities center and tell them this is a drawing, give them a drawing and say this is what I want it to be manufactured. They manufacture and give it to me. Of course, I need to pay something, but it's a shared facility. It has facilities which I won't have been able to invest on, CNC machining, electronic mass assembly, R&D facilities, X-ray facilities, all kinds of things. So it makes a lot of sense for, I think we already have a MOU with DSU for joining together and assisting each other. So you can leverage that MOU to visit the cluster facilities, carry out projects instead of just taking up theoretical projects in your university. Take up an industry problem. It could be on the software, it could be in the hardware, it could be a manufacturing problem. Come up with a solution. It'll be a good learning for you, good service to the industry also. So it can be a win-win situation. And if we are pretty close by, ideal situation, we need to do a lot of things together. So it's definitely a lot more things can be done. We have to get started on that.
Yes, sir. Yeah. Personally, I have seen, as I mentioned, I am so impressed with the facilities what you are having. Only thing is with the students, how to utilize the facilities which are there by the students. That's probably important step we need to take it, sir. I remember the MOU, sir. We have the MOU with the
Yes.
LSHIA. Definitely, it will be very helpful for us. Yeah, we will come up with the students visit. Then probably down the line we will try to have some kind of the internship or taking the projects from you and work towards that.
Correct.
Yes, sir. And coming to some other questions. The other, sir, we have Professor Umesh. He joined from the UVCE, University of Visvesvaraya College of Engineering. And his question is mainly on the how to train the rural students in engineering subjects and to develop the skills in thinking, doing something on their own. It's a very generic, sir. Yeah.
Well, that you have to go back to my slide where I showed my son learning the same way as I learned from my father. My father was a mechanical engineer. In fact, he was a gold medalist from UVCE way back in the early 20s. So he hailed from Gorur, which is close to Hassan. In the Hassan district, you have the Hemavati Dam there right at the village. And therefore, from there, he came to Bangalore to do his engineering. Those days, I think he stayed in a hostel. I'm talking about mid-20s, and subsequently went to Germany to get a post-degree diploma in industrial engineering, worked in the German railways for 2 years during Hitler's days. And so he knew about how engineering was encouraged in Germany, and he adopted that inside our own family. So right from day one, almost from my birth, I've been exposed to all the kinds of tools. He used to pull out his automobile car engine, not only his, but other friends' cars also. Pull out the engine, put it in the veranda of our house in Delhi and repair it. He used to do reboring, ring change. I've seen it as a kid of 5. So that is what is required. Encourage people to use tools, whether it's start with just a simple screwdriver, digital multimeter, which is available for 250, 300 rupees. They must use it on a daily basis in their homes. That's the way to get started. And then, of course, in your college, the labs, encourage them right from semester 1. Make it fun. A lot of things will get damaged in the process. I can tell you that. But don't be afraid of that. So you teach them, the correct methods of, you must have a do's and don'ts. We adopt this in our labs. In spite of having full-fledged graduates in our R&D labs, we still experience this. They connected the power supply reverse and the whole thing goes up in smoke. The whole one board is gone. Maybe 5-6 months of work is gone up in smoke. But then you need to take preventive measures to prevent such accidents happening. And also, that's where the hand holding comes in. So right from day one, encourage people to get their hands dirty, build some things. In fact, if you make it fun, they will come anytime, even after their class hours, they will come back to the labs. Keep your labs open till 8, 9 o'clock. I'm quite sure it will open up their minds. That's required.
Yes, sir. It's really great to know about 3 generations, your father and you and your son. Hopefully it will continue in next generations. That's great to know. Great to know, sir. Big salute to you and your family.
Thank you.
So other questions, sometimes innovations lead to job crisis. Your opinions on the upgradation or automation. What is your opinion on that, sir?
See, this argument was put forth 40 years ago, 30 years ago, let's say when computers became available, even before PCs came in, we had the mainframes. And many of the banks wanted to use computers so that their jobs could be done faster without errors. Because when you start manually posting from so-called journal to a ledger, there is a possibility of an error. 1,000 rupees can be entered here as a 1 lakh or 100 or some error and going into a wrong account. So all those are eliminated when you have a machine performing it with a pre-programmed software running on it. So there was a lot of objection from unions in the bank saying computers should not be used. Thankfully, we had Rajiv Gandhi as a prime minister under very tragic circumstances. He took a bold decision saying, yes, we will adopt computers into all banks. That did not throw out jobs. How many banks multiplied? Because once you use automation, manpower can be used. Manpower, the brain of a human being is far superior to a machine, in spite of artificial intelligence. So I say that human brains will automatically get elevated to a higher level of operating, which is what you can see. Now people are using computers at a higher level to generate output of a higher value. And therefore, automation has not killed jobs. Automation has created different kinds of jobs. And therefore, you have more people capable of doing this thinking act, which a computer cannot do. Artificial intelligence, whatever you do, is still artificial. It's not natural intelligence. Natural intelligence has the ability to take hundreds of parameters in a different situation in the context and come up with solutions, decisions as appropriate to that particular instant. So I hold the view that automation and the use of computers, robots is not going to throw people out of jobs. They will temporarily be thrown out of some jobs, but they have to be accommodated in some new jobs that will get created. And we need to do that.
So that question here is there any saturation point? So beyond that, man is not required.
No. There used to be science fiction movies, I think also based on books, where ultimately a machine, complete robot takes over and then starts killing man himself. I don't think we'll allow that to happen. We will definitely prevent that from happening. In fact, many people are wondering at the start of this COVID crisis whether this is one of those situations where it's trying to kill mankind itself and take over this whole world. That won't happen. We have human, I think, intelligence is far superior to any kind of artificial intelligence with the best of programming. So ultimately, I think we will win and we'll have retained the control to whatever happens in the future. And we will find new activities, new areas where we will employ the same human being. Maybe a question of retraining, reorientation of the people is required. But ultimately, it will assist mankind.
Yes, sir. Yeah, thank you. The next question is, students wants to know and listen from you, sir. What is the biggest challenge in your life you have failed? You have experienced. Probably it's on the failure side, and how you overcome that.
Let me tell you, nobody talks about or writes about failures. In rare instances, some people refer to the failure briefly to say, okay, ultimately how they converted that into a success. But I can tell you that almost everybody, every organization, whether it is small, medium, large, multinational companies, Fortune 500 companies, everybody makes mistakes. And making mistake is part of learning. So when you learn, when you make a mistake, you have to have the boldness, the guts, as well as the eagerness to analyze it. It's almost like dissecting a dead animal or a human body to say, what did I do? What did I think was correct? What way did I make a mistake to make this whole thing into a failure? But that's where I go back to the art of learning and the acquisition of knowledge. So if you've gone through that process and you've got this art of learning, which I call as an algorithm, of analyzing anything, whether it is a failure or a success. Even a success or a failure, you can analyze, saying, why did it succeed? Why did it fail? Each step, break it down, saying, yes, this could have been done better. Even though it was a success, maybe I could have done it even better through some other process, through some other method. So that analytical ability is what is most important. Now, when somebody asked me about this question, about what was my greatest point, I won't call it a failure. The fact that I quit a public sector job, which is a guaranteed job. You can't really get fired from a public sector job. I would definitely have retired as maybe a general manager or a very senior position. Some of my other batchmates retired as a managing director of HAL. So we were taken in as blue-eyed boys in the form of management trainees, trained very well over an 18-month period and posted to different divisions of HAL. And aerospace by itself was my childhood interest. I used to started with paper models, then some cardboard models, and then static models, scale models of various. In fact, when I went for the interview at HAL, I carried a box full of solid scale models of various aircraft. There are 5 or I had a collection of about 25 wooden models which I had made with on my own hands. So they saw that I was deeply interested, and therefore they had no hesitation in selecting me. So I was keenly interested. I wanted to be an aerospace designer, and that's why more or less my ambition was fulfilled when I was posted into the design department. To quit that position was definitely a low point in my career. It was a hard decision, but I said, I had already got married, but I didn't have yet any kids. And so I said, it's either now or never. And I was not happy working there because I didn't see the challenge. I didn't see too much of a future there. Even if I got promotions and reached the point of a position of a general manager, you need to have a challenge and then the satisfaction of tackling that challenge and coming out with a success. That's what every one of us should aspire for. Every one of us should look for in any job. And I go to this extent of saying my salary packet, pay packet is very, very insignificant as far as I am. Okay, if it can meet my, both ends meet, I'm happy. But a larger part of that intangible salary is not in rupees, but in the satisfaction and pleasure I get out of carrying out my task as an employee in an organization or even as an entrepreneur. That's far more important. You can't quantify it into so many rupees or etc. But you can, if you make an attempt, you will say that's far more than the pay packet I'm taking home. Then you get so absorbed in your life that you are thinking about your challenges day and night and you enjoy it. So that negative thought there at that point of time, thankfully I had the support of my wife who said, I have enough confidence in you. If you're not happy, quit your job. I know that you can do many other things. I'll help you. We can both do together. And that's how we ended up creating a company where both of us are partners. Later on, both of us are directors. To this day, both of us share our entire work 50%. Sales and marketing is handled by my wife. R&D is handled by me. Little bit of production because I have a production team by now fully trained, they can handle. So once I hand over my design documents to the production, they will execute it. So there is no point in looking at anything as insurmountable. And that comes out of this confidence saying, I have overcome so many obstacles, I can overcome many more. That is what children and the students need to develop.
Thank you, sir. Thanks for sharing your wonderful experience. Sir, we are really happy to know the two things what you have mentioned. The one is the satisfaction and the other one is the happiness.
Yes,
Really,
happiness.
yeah.
Happiness, in fact, happiness is the core of everyone's life. That should be the main ambition. Everyone needs to be happy. And happiness can not just come out of a pay slip which has 5 digits or 6 digits or 7 digits. It has many more other parameters which have an intangible value, but you need to attach value to that.
Yes, sir. Yeah. And personally, I know about your love with your wife. I think you have mentioned that Radel. Radel
Yes,
came from the your wife's name, Mrs. Radhika.
that's right.
Students actually, Sar's wife name is Radhika, and he wants to keep her name. So he started with the Rad. He brought from the Radhika, and in his interest in electronics, he added the EL. So he kept his company's name as the Radel. Thank you, sir. Thanks. Yeah.
Welcome.
Going to the next question. Sir, what are the chances of someone stealing an idea from another person who had at the first place?
Very good chances. That's unfortunate, more so in this country, because the courts don't work in this country. I'm sorry to make this statement, but when you say justice delayed is justice denied, recently there was a news item that somebody who was shot by the police had to wait for 35 years before judgment was pronounced last week in, I think, in Rajasthan. 35 years. You call that justice delivered? No, that's not justice. So same way, whatever you develop, whatever you design, you need to protect it suitably. Now that's a separate subject by itself. You can have a talk from any consultant on intellectual property rights, but it's something you need to be aware of and ensure that you don't reveal the secrets of your design or innovation before you file for a patent or a design registration or something, because failing which, even in spite of getting an IPR, design patent, some people will still copy your design, and then the only recourse for you is to file a case. Now that fellow may be hiding anywhere in the country. You will have to spend a lot of money running after him to catch him, and ultimately if you need to proceed against him, you'll have to file a raid using the police. All that involves a lot of time and a lot of money. And I say money, you can imagine what kinds of money. So it's a problem in this country, and that is why it's a very, very tough survival for people who are innovative, who have design skills, etc. But that should not demotivate people. You need to have a method of protecting your designs, protecting your ideas, and then hope for the best.
Thank you, sir. The next question is from the faculty member, and she is asking, how can we adopt teaching processes that are appreciable by both urban and rural students?
You see, what I do, whenever I want to explain any concept or a subject, I try to use an analogy to a domain where the student is familiar. So, it becomes difficult to explain electrical engineering or electronics because it's all abstract. You can't see an electron traveling. You can't see a current flowing. You can see water or hydraulic oil flowing in a hydraulic system. So if you adopt an analogy to say current is like the flow of water in a water pipe, and the pipe is equivalent to a conductor. The water can only flow inside the pipe wherever the pipe is rooted. The wire also is flexible, so you can conduct the current through a wire to a place where you want that current to be applied to a load. So like this, you have to use an analogy. So if I use today in my presentation the analogy of a tree, I did it purposely so that everybody has seen a tree. Everybody has access to visualizing. You don't have to visualize. You can actually physically see. So you can see the branches of a tree, a trunk of a tree. And when you dig, if you're a gardener, you see how deep the roots go. I do a lot of gardening at home, and I know that these unwanted, unwanted plants, they have roots that go so deep that it becomes very difficult. And every time I do that gardening to try to remove it, I think of corruption in this country. You can't eliminate corruption because it's like that, those kind of plants which can't be uprooted. It'll keep on growing. So the answer to this question is that you need to give an explanation in relation to the topic or subject you are teaching, using an analogy in which that is what I meant by, in my slide, I said, use the teaching approach as understood or as capable of being understood by the student. So you might, from a rural background, definitely they'll be used to plants, trees, and so on, so on and so forth. If there is something that can't be used using that analogy, at least use an analogy where he can see, like I said, pipe, water, oil, gas, things like that.
Sir, thank you. Yeah. Any other questions? These are the questions what I have received till now. Students and faculty, any other questions? Please drop immediately. Or you can raise your hand. Probably we can allow you to speak. Any other questions? Looks like they don't have the questions, sir. Other questions probably
Fine, okay.
will come back. And
But that's another thing I want to, once again, at the point of closing down, I want to encourage students, because unless you get into the act of asking questions, even a presenter will get demotivated, because you think that nobody's understood, nobody was interested in that talk. And so it can give a negative feedback to the speaker. So there should be, and I don't know how the faculty or anybody has to, you need to encourage students to ask questions, trigger them, cajole them, prepare them in advance, whatever you need to do, but that needs to happen. Only then it can be a healthy relationship where the speaker understands or thinks that he has delivered some value to the prospective engineers coming out of your colleges. So it has to be something that is pursued continuously by all staff members, even including in your own classes. Encourage students to ask, prompt them,
yes, sir. Yes, sir.
prompt them.
Yeah, I feel that this session definitely still some people have the tendency of having the little shy in asking the questions, but definitely yes, sir. They are really interactive in our day-to-day classes. But unfortunately, during this time through the online, we have feeling some difficulty. Otherwise, they are active, sir.
Okay.
Yeah. If there are no questions, probably I want to convey our sincere gratitude and thanks to you, sir, on behalf
Thank
of
you.
departmental faculty, students,
Thank you.
and at the
Thank
same
you.
time from the university. We are very grateful to you today. It's a wonderful time, sir. Thanks for all your time. Even though we planned for 11 o'clock, I think it became 11:30. I'm sorry for
Yes.
a little delay, but
No, no
really
problem.
we all enjoyed your speech, and we all are inspired by seeing the lot of energy with you. And hopefully we will learn many things, sir. Many things about today's session is
Uh, Can I
I
just suggest one thing? If you can give me comments from students as a feedback, what they learned, what they liked, what they did not like. I don't mind any negative feedback also. I'm one of those who doesn't take to heart anything negative as long as there is something constructive there. So encourage your students to send me a feedback. You can collect everything and send me a total feedback from students as well as faculty, whatever anybody wants to say.
Sure, sir. Sure, sure. It's our fortune to have. Thank you, sir. Once again, our sincere thanks to you and best wishes to your family members, sir. Thanks a
Thank
lot, sir.
you.
Probably we
Goodbye to
will
everybody.
plan some more session in the down the line. Till then, thanks a lot, sir.
Sure, 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 sure. Bye-bye.
Signing off now.
Yeah.
Thank you. Thanks for all your participants for your patient listening. And as sir was mentioning, probably we will send you a kind of the feedback form. Please fill your information. And if any questions you are feeling difficulty in asking now, you can list those things in your feedback form. And we will communicate to the sir. And once we get some reply from him, we will communicate to you. Otherwise, thanks a lot. Have a great time. Thank you.